So today we're going to talk about Chapter 2, Section 2. It's basic differentiation, which we're going to come to know as the power rule. Yesterday during class we realized that there was a pattern developing that if I had the function equal to x squared, we realized that the function, the derivative, would be 2x. And that is the power rule. So the power rule basically states that if you have x to some power, that the derivative is going to be n times x to the n minus 1 power. And note down here we say always turn all the x's into exponents, meaning get rid of the radicals, put them in fraction form, and get rid of any x's in the denominator, meaning put them as negative exponents. So go ahead and try to apply the power rule to these four.
Pause here.
So if you did it correctly, you would have found that the derivative of x to the fourth is equal to 4x cubed. The derivative of x to the 12th is equal to 12x to the 11th. The derivative of x to the negative third power would be negative 3x to the negative fourth power. Remember that it's the x to the n minus 1 power. Negative 3 minus 1 is going to be negative 4. That's pretty tricky. This one we would rewrite as x to the 1/2 power. So then I would say that the derivative is equal to 1/2 times x to the negative 1/2 power. I'm just taking the old power, putting it out in front, and then subtracting 1 from the old power. If there's a coefficient, then I would just say, well, here's my coefficient, and here's g of x. Well, the derivative of that is going to be the old coefficient times the derivative of g of x. So then I would say this would be 3 times 4x cubed, or 12x cubed. Another way of putting it is if I have c times x to the n power, c being a constant, then my derivative is going to be c times n times x to the n minus 1. So that would be 3 times 7 times x to the 6, or 21x to the 6. Go ahead and try it on these four.
Pause here.
Right, so if you did this first one right, you would have the first derivative is equal to 15x squared. This one over here, I would think about rewriting it as 7x to the negative 1 power, and the derivative, which I'm going to be lazy and use y prime, is equal to negative 7x to the negative 2 power. This one's already rewritten for me, so I can write y prime as equal to negative 6 times x to the negative third power. This one I got to get rid of the radical, so I'd rewrite this as 5x to the 3/2 power. I'd multiply my old exponent times my old coefficient and get 15 over 2x to the 1/2 power. Alright, so what about if the function is just 7? F of x equals 7. Well, this one's a little bit trickier. Well, we think about what's the exponent on x? Well, technically that's x to the 0 power. So I follow my method and I say f prime of x, the derivative of x, would be equal to my old coefficient times my old power times x to the negative 1. Well, that is obviously just going to be 0. So every time we take the derivative of a constant, it is going to be equal to 0. So if f of x is equal to a constant, the derivative of that function is going to be 0. And that makes sense, because if we look at the graph of that constant and we think about the derivative as the slope of the tangent line, we would see that if I drew a tangent line to that line, the slope would be 0. I can do the power rule separately, which means that if this function is described as this whole thing, I can find f prime of x by doing each monomial independently. So the derivative of x to the 5th power is 5x to the 4th, plus 4x cubed is 12x squared, minus 2x squared is minus 4x, and the derivative of 9 is going to be 0. So I can use this to work on problems like this. Find the slope of the tangent line at x equals 3, x equals -3, and x equals 0. Well, the slope of the tangent line, remember, is the derivative. All right, so I need to find the derivative. We would say f prime of x is equal to 3x squared minus 4x minus 4. Now I'm just going to do this at 3 and find the slope of the tangent line at 3. I'm going to leave you to do -3 and 0. So if I plug in 3 here, I get 27 minus 12 minus 4. So the slope of the tangent line at 3 would be 11.